Hey guys, this video is going to introduce you to one of the most important changes in world history. We'll be looking at the scientific revolution, looking at what science is, why science developed around the time that it did, and what some of its effects were. Here are your video goals. Make sure you memorize these vocab words and have some kind of answer to these questions. Alright, so let's go ahead and get started. So what was the scientific revolution? The scientific revolution was when a new way of seeking knowledge about the world developed. Specifically, it was when science became the dominant way that people tried to understand the world. This way of looking at the world developed around 150 years, from 1550 to 1700. So during the same time that the Renaissance, the Reformation, the voyages of exploration, and absolutism were occurring, and it's connected to all of those things. This is one of the most important intellectual advances in history. It's super important because by gaining more knowledge about the world, European societies also became vastly more powerful. It unlocked new technologies and allowed them to do things they'd never been able to do before. And it resulted in increasingly rapid technological change and also social change, because as technology got better, societies changed and as they adapted these new technologies. So, one of the most important things that I want you guys to think about is, why did science happen in Europe around the year 1600 instead of happening in any of the other civilizations that we've studied? And the reasons are complex. There's a number of different factors, and it's connected to all of the other things we've learned about in this chapter. First of all, the scientific revolution what happened because of various ideas and technologies that Europe got from other cultures. Specifically, the technology of printing, which originally developed in China, allowed for ideas to spread around Europe. Advanced mathematical concepts from India, specifically the decimal system and the concept of zero, made scientific predictions possible. And alchemy from the Middle East was the early ancestor to chemistry and was one of the first kind of like pseudo-scientific ways of investigating society, or nature rather. So Europe got a lot of its key stuff from other cultures. But some of the things that Europe did starting around the year 1500 also were crucial for the development of science. One was the Renaissance. Specifically, the Renaissance philosophy of humanism was one of the underlying motives for science. Humanism argues that human beings are intelligent and that by thinking hard about the world, we could make the world a better place. That's more or less what science is all about. It assumes that if we understand the world, if we think about the world, we can understand it, and if we understand the world, we can change it in a good way. That's the Renaissance. The voyages of exploration were important for a couple of reasons. One, it proved that a lot of old ideas were wrong. For example, it proved that the Greeks did not actually know very much about the world. For example, the ancient Greek philosopher Aristotle confidently claimed that that the Earth was in the center of the universe and that there were only 3 continents. Obviously, both of those are wrong. Perhaps more importantly, though, is that the voyages of exploration and the conquest and trade that the voyages of exploration made possible provided money that was crucial for funding scientific experiments. If you're poor, you're not going to spend money on science. But if you have plenty of money, then you can invest in scientific experiments and research. And last of all, the rise of absolutism was another key motivation for science. As kings centralized power and became more and more wealthy, they were then able to spend some of these resources on financing scientific discoveries. Kings realized that science was crucial to power. So kings that invested in science could expect to receive certain benefits, like better weapons, stronger buildings, that would come with more advanced scientific technology. So all of those things combine to help the scientific revolution to happen. Over there you can see a picture of Leonardo da Vinci's dream of a flying machine. He was a Renaissance thinker who was already dreaming about advanced scientific technologies. But so, what is new about science? So, science, in some ways, is similar to older traditions of philosophy and religion. So like religions and like other types of philosophy, science asks questions about how the world works. Scientists want to know what is going on in the world. And they look for patterns of cause and effect. They want to know why things happen. And last of all, science does, like religious theology and like other types of philosophy, use rational thought to figure stuff out. Pretty much all philosophers and most religious thinkers throughout history did these things. But science does some new stuff that makes their ways of thinking more powerful and more useful. So what is new? First, science bases itself on the idea of empiricism. That's a fancy word for basically limiting your beliefs and your explanations to things that we can actually observe and measure. In science, if you can't observe something, it might as well not exist. So science gets rid of everything mysterious, yin and yang, God, and instead focuses on things we can measure, like speed, time, weight, stuff like that. Second, another thing that science does that is new is it bases itself on experimentation. It's basically, if you have an idea, you need to test it by setting up an experiment that will prove you right. If you can't somehow predict what will happen in an experiment, then your idea might be wrong and is probably not very useful. Third, science believes in building new tools to increase what we can observe, to enhance data collection. So for example, since you're limited to what you can see, you might need to expand what you can see to really understand the world. And that's why scientists built stuff like telescopes and microscopes to expand what we could observe. And last of all, science bases itself very heavily upon mathematics, because mathematics is the most precise way to measure and model what we observe. And that's one reason that mathematics is so important in modern education, because you can't really do science without mathematics. So anyway, the combination of empiricism, experimentation, building new tools, and mathematical modeling results in a new way of acquiring knowledge, and this knowledge is accurate, testable, and useful. So we're going to now close by looking at an example of science in action. And we're going to see how over the course of 150 years, science goes from a totally fake, unrealistic view of the world, which you can see on the left, to a very advanced and powerful view of the universe that explains all sorts of really cool stuff. So, at the beginning of the scientific revolution, everybody believed that the Earth was in the center of the universe. This was called the geocentric model. And this model dates all the way back to the ancient world of Greece and Rome. The specific geocentric model that Europeans believed in was developed by a guy named Ptolemy, who lived in ancient Greek-speaking Egypt in Alexandria. And Ptolemy believed, and you can see the picture over there on the right, that the Earth was in the middle and that the sun, as well as all the other planets, revolved around the Earth. And this explained why planets moved around in the sky, but the stars stayed still. He believed that the stars were the outer edge of the universe, and that radiating out from Earth were all the other planets moving in perfect circles. So, what are the advantages and disadvantages of this view, scientifically speaking? Well, it did have some major advantages. One is it explained why the planets moved around in the sky. Two, Ptolemy had actually worked out a very careful system that allowed for people to do math and predict where planets would be in the future. So this system could be used to tell you where Venus would be in 20 years. Or you could also use it to predict solar eclipses. So in this way, it was actually a pretty powerful system. And last of all, this was a good system for a lot of people because it fit with the Christian worldview. There are certain passages in the Bible that seem to indicate that the Earth is in the middle of the universe, and that the sun moves around the Earth. So, since most people were Christian in Europe, this view made a lot of sense. However, there were some big problems with this. One, the math to make the whole thing work was insanely complicated, and it would take forever to work out where things were going to be. Two, the predictions that it made were not super accurate. And three, there were some astronomical events that this model just could not explain. Like, for example, what were comets? How did comets fit into this system? There was no real good explanation, and there was no way of predicting or explaining how comets would behave. Now, in 1543, this changes. A guy named Copernicus, who is actually a Polish guy working for the Catholic Church, develops a new model of the universe. And he argues that the sun is actually in the center of the universe and that the Earth is just one of many planets. And this was a stronger view scientifically for several reasons. One, it explained the movement of the planets just as well as the geocentric model. Geocentric means Earth-centered, heliocentric means sun-centered. So the planets could be explained as moving equally well using either system. Also, this could be used to predict the movements of the planets, and as the system got better and better, it could predict the movements of planets with more and more accuracy. And last of all, the math for this system was much easier. However, there were also disadvantages here. It couldn't explain some astronomical events, like it still couldn't explain comets. It did not explain why planets moved this way or why planets moved around the sun at all. And it did go against the Christian worldview, and some people got in trouble for proposing this idea. Most famously, Galileo, who was put on trial for arguing that the Earth was not the center of the universe. But now, we're going to move way beyond this into something way more powerful and scientifically impressive. And this is Newton's laws of motion and gravity. So Newton wasn't just interested in knowing how the planets moved, he wanted to know why the planets moved. So he developed a theory that explained all of this. And here is Newton's theory. Newton believed that space was infinite, and it was an empty void, and that objects moved around through space. And then he came up with certain mathematical laws that explained how things moved through space. And the two sets of laws were the laws of motion and the law of gravity. So the laws of motion said that basically all objects that were moving through space would stay in motion until they were acted upon by some other object. So if you threw a rock in outer space, that rock would just go forever until it hit something or was affected by gravity. So the second thing that Newton talked about was gravity. And he said that, that all matter attracts other matter to itself with a force that diminishes as things get further apart. So as you get closer to something, it will start to suck you in towards it. And that is why we move towards the middle of the Earth, and that is why black holes suck things into them. Matter sucks things in towards itself. And so if you combine motion and gravity, you can explain why all things move the way they do. This includes planets, but it also includes things on this Earth's surface, like cannonballs. This is an insanely powerful idea because it allows you to use math to explain exactly how things will move. And this is good for predicting where planets are, but it's also good for predicting how cannonballs will fly through the air, which can be very useful. So this is a super powerful theory that allows us to explain way more stuff than ever before. And its only real disadvantage is that it's kind of scary. And this is super important because science makes people more powerful. Newtonian physics allows for all sorts of amazing technological advances. For example, it allows for better maps, better navigation of ships by using the stars to navigate, and more accurate cannons. And this is evidence of Francis Bacon's famous quote, "Knowledge is power." And after this happens, European societies are going to realize that whoever has the best science is going to be the strongest and is going to win. All right, guys, that's it for today's video. Here are your goals. Thank you very much. That's all I have for you today.